Hello, good morning for science one.
Morning, sir.
Yeah, morning everyone.
Morning.
Okay. So once again, I meet you for the second time in this week, in February. This is our second lesson. Okay. So I would like to start straight away now because 8:30 sharp, I have 9:30 sharp, I have to stop now because I got another class. Okay, now I start sharing the paper for science one. Okay, I think it's somewhere here. We stop. Correct? Not this one. One moment now, because someone is coming in, so I need to click. We stop at question 11, correct not? Is it question 11 now? Correct not? Please check for me, okay? Marcus, is it question 11 now? Marcus, where are you? Ng Jing Yong say yes, so I think it's correct. So now we continue with question 11, correct? Okay. Charisma, can you confirm? Is it question 11 now? Charisma? Correct not? Charisma. Okay, thank you, Charisma and Jing Yong. Okay, we look at question 11. The question sounds something like this, a student plot a graph for physical quantity. Q is x and y axis, so the Q is y. Against a physical quantity R on the x, so meaning that Q is y, R is x. So the equation given is like that. So you see, I copy the equation, so I bring the AR over right-hand side to become positive. Why I do that? Because I want this one to be in the format of strict line formula. Y equal mx plus c. Now you check, y is q is correct. X is r, so correct. So now we already know the gradient m is a. Okay, so the answer is a. So gradient m. You all know, right? This m is gradient, and then the c is what class? M is gradient, then the c is what?
Y-intercept.
Y-intercept. So m gradient a, y-intercept is p, but they never ask lah. Okay, so solve this question already. Okay, now question number 2, a little bit difficult this question. Okay, come, let's see how to solve this question. Resistance R, this is resistance. Temperature is capital T. This is temperature, this is resistance. For an electric conductor given by the formula. Formula given already, so we just use the formula. R is a resistance at 0 degree. Resistance at 0 degree, okay? And A as a constant. Okay, graph RT already given. What is the resistance R of the conductor when the temperature 60, mean the T60 now. When T60, what is the resistance R? So using the formula given, okay, now you can see from here now, Y is R, M is A, Y equal to MX plus C. Why not? This one already given in the format, this is Y. Always remember, no, Y equal to MX plus C, MX plus C, all right. So Y is R, X is a T, memang correct. So A is a gradient now. So gradient you can find from here. So gradient is 3 divided by 2. So over here is 3. This gradient is positive, so ignore the negative. So it's 3 divided by 2. So gradient, you know the answer already. So you put here 3 over 2. And temperature given T60 is given in the question. So put here 60. R is a y-intercept C. Now you see here, y-intercept is 3. So the R replaced by 3. So you calculate, you get 93. Okay, can I understand? Joel, do you understand?
Yes, sir.
Understand now? Okay. Some now come in. Okay, now let me click them first. Admit them to come in first. Okay. For those who just came in, please send your attendance. Okay. Okay. Now next question 13. The equations of the graph. First thing, calculate the gradient. Gradient is 10 divided by 5. So it's negative because this one go downhill. So the gradient is negative. So you put negative 10 divided by 5. So you get -2 as a gradient. And y-intercept here, you see the line cut the y-axis at number 10. So C is 10. So use a formula. Y replaced by P. M gradient replaced by -2. X replaced by Q. And the y-intercept C replaced by 10. That's all you get the answer. So, okay, for size 1, can I understand? Where is Marcus? Never heard his voice. He's not here, Marcus. Marcus here or not? Let me check the name. I think Marcus not here yet. No, what happened to him? Marcus not here yet. You know what happened to him? Something wrong. I think he's still on bed. Okay. So 13 finished already. Now 14. The following figure. Excuse me. The following figure show the graph V versus U versus V. The graph given. So that's how you get the answer. From here, find gradient. Gradient is positive, so it's M. The length here is M. Here is M. Gradient is M divided by N. And the y-intercept is here. The line cut the y-axis at M. So y-intercept C, C is M. Okay. Now you just use a formula. Substitute the y with U because U is a y-axis. Gradient is M over N. X-axis replaced with V, so you put here, and y-intercept C is M. Okay, that's all you get the answer. So it's A. Okay, Ahmad, understand? Ahmad, you understand? Can I understand?
Yeah, sir. Yeah, can.
Okay. Come, we move to the structure question now. There's a lot of things you need to do, this morning. Okay, number
sorry,
15.
excuse me, sir.
Yeah, why?
For the formula of gradient, isn't it supposed to be negative y-intercept over x-intercept? So the answer should be B.
You mean this question, John?
Yeah, yes.
Why this gradient is negative? Why you say it's negative?
No, I mean the formula for gradient is negative y-intercept over x-intercept. Because this gradient is supposed to be positive, but if you see the graph, M is a positive value, but N is negative. So if you just do like that, it will become a negative value, right?
No. It's definitely wrong, You look at the line gradient should be positive, not negative. It's going uphill. It's
Yes,
going
sir,
uphill.
but because M is a positive value and N is negative, so the gradient will come out negative, right?
No.
So
I know the formula is negative y-intercept divided by x-intercept, isn't it? So
yes.
negative, so you put in negative M divided by the N itself is negative actually. It's on the left side. The N is supposed to be negative. John, do you get it or not? Because N is here, it's supposed to be negative lah.
Oh,
Understand?
okay.
Then negative cancel, become positive. Okay, actually, very easy, you to recognize which is positive, negative. You see the line. When the line go uphill, gradient definitely must be positive. Cannot be negative, John. Understand?
Okay, thank you, sir.
Go uphill, go downhill. Understand? All right. Okay. Now question 15. All right, these questions are students carry out experiment to find out. Yeah. Sometimes when the message are blinking, I have to click and see. Okay, sorry. A student carry out experiment to find out the relationship between the change in the length of the spring, change the length of the spring, and the mass of the load. Okay, the concept of this experiment is like this, this is a spring. So you are putting this load on top. Then you see what is the change of the spring, change in the length. Okay, concept very simple. The more load you put up here, the length of the spring will decrease, right? It will compress the spring. So the more load you put up here, so the change in the length become bigger. So the length becomes shorter, so the change is bigger. There is a relationship. So for example, maybe you start with put 0.5 kilo, you see what is the change in the length. After that, you put 1 kilo, what is the change in the length? That's a very simple experiment. Okay, now you see the experiment manipulating the mass of the load. So start with 0.5 kilo, 1 kilo, 1.5, and so on. So the diagrams already given, the spring, or say what you need to do is you take out a ruler now, class. Because your paper and my paper may not be the same. So what you do is like this, First one is the original length of the spring. No load. No load means you never put anything here. So this is the original length. Class, this is the SPM question. What you need to do now is you draw two lines here, one on top, one at the bottom, then use a ruler to measure the length of the spring. So this is the original length. So on my paper, I measure it was 8.8. Can you do on your own? Your graph, your printed paper may be different. Okay, please measure it. Take out a ruler. Do all the measurement. Measure this one. Second one, you put 0.5 kilo. So it will compress the spring. So it becomes shorter. So please measure. Don't copy the answer. You have to measure it on your own paper. So mine is 7.9 and so on. Okay. So do it now in 2 minutes time. Get all the measurement done. Length of the spring. So mine is when you put 0.5 kilo, it becomes 7.9. When you put 1 kilo, it's shortened, now becomes 7.3, 2. And 1.5, it becomes 6.2. And you put heavier, 2.0 becomes 5.1 and so on. Okay, please do it now, everyone, on your own paper. Your measurement may different from mine, okay? Don't copy from my answer. Yeah. Done, everyone? Joel, have you done? Have you done all your measurement, Joel?
Not yet, not yet. Wait.
Okay. Please do it because later on you need to plot the graph. You need to plot a graph today, and then I want you to take a pictures of your graph, then send into the group later on. So please get ready. Okay. After you measure the length of the spring, right? So what you need to do now is you calculate the change in the length. How to calculate the change in the length? You do like this. Original length is 8.8. When you put 0.5, it becomes 7.9. So the change is you minus 8.8 minus 7.9. So you get 0.9 cm as a change in the length. And then for the second one, you put 1 kilo, it becomes 7.2. So the change in the length is you take 8.8 original length minus 7.2. So you get 1.6 and so on. Okay, please do all the calculation, calculate the Y value, the change in the length of the spring. Okay, do it now. Follow your own diagram, okay? The paper you printed out may be different. The length can be different one, okay? It depends on what printer you are using. Okay, do it now, everyone, class. Done all the calculation?
Not yet, not yet.
Not yet, not yet. Okay, Joel, very slow, Joel. Do faster, Joel, please. I know who you are, no, Joel. Always I met you in the school one, Joel Lim.
Okay, sir, can.
Okay, done. Okay, everyone, you have done this. Okay, now we move on to the next parts of the question. Okay, now you see. First one is manipulating variable. They ask for this thing. Okay, so manipulating is mass. You manipulate the mass because you started with 0.5 kilo, then 1.0 kilo, 1.5. Very obvious. Manipulating variable is the mass. Responding will be the change in the length. Y, change in the length of the spring. Constant variable, something must be stay constant, right? The one is diameter of the spring coil. The diameter of the spring must be the same. Okay, as long as you don't change the spring so meaning that the diameter not issue is the same. Class, I want to ask you why the diameter of the spring coil must be the same? Jiang, why the diameter of the spring coil must be the same? The diameter means here the spring diameter is like that. The spring is coiled like this, right? Did you hear the diameter is here? Why the diameter must be always say the same diameter of the spring? Diameter is a very ugly my diagram. Why the diameter must be the same?
Because different diameter maybe can withstand different amounts of weight.
Yes,
so it must stay the same.
Yeah, enough for the teacher. Your answer is very good. Thank you. Because different diameter will affect the stiffness of the spring. It will change the stiffness. Okay, diameter big, the spring is very soft. When the diameter small, the spring become very hard. It's different one, Hard means we say stiff. Okay, all right. These are okay now, all right. Next one. Length of spring in figure 2, L0. The original length I measured is 8.8. So you copy your own answer now. Original length. Okay, next one. You have done all the measurement. Please prepare a table. So the table you have to follow M, L, and Y. 3 columns. The mass, the length of the spring, the change in the length. Okay, please prepare a table like this. The mass in kilogram, the length of the spring you measured is also in cm, and the change in the length also in cm. Okay, please complete your table now. Okay, your table give you a lot of marks, 5 to 7 marks. Please do your table properly in the exam. Okay, done with this or not? Make sure your table you have all the symbol, all the unit, and the number of decimal place or places for each column must be uniform. The one you learn already, right? If you choose one decimal, all must be one decimal. If two, all must be two. Okay. I mean for individual columns, not the whole table. Understand? From one column to next column, the number of decimal places can be different one.
Generally put for 0 kilos.
Yeah.
No, because he said figure 3, 4, 5, 6. And so you follow the question now. It's like that.
Right.
The question say for this one. Figure 3, 4, 5, 6, 7. That's all. So we follow exactly the question. Okay. Aslin, understand? Aslin Lim. Okay.
Yes, yes.
Done already or not?
Yeah, yeah.
Done. Now today your internet okay, Aslin? Aslin won't talk much one. I know that the sister also like that one. The sister character is doesn't talk much, huh? Where's your sister now, Aslin?
At home?
Huh?
At home.
She's studying, right? Supposed to be doing what course now?
I don't know. She's entering uni next month.
Oh, okay, okay. Good. Huh? All right, next one. Next one, the question. Okay, we see here now. Okay, now they ask you to plot graph. Okay, I want to ask you all first lah. On the graph paper, plot a graph y against m. How you plot that y against m? That means how, where is y, where is m? I want to ask your opinion first. If the question say plot a graph y against m, so where are you supposed to put y? Where are you supposed to put the m?
Y on top.
Huh?
Y on top.
Yes. Y must be here now. Remember now. This is a standard way we say y against m. So y always started here on the x-axis, y-axis. M is here. Okay, but you have to put the units. M is in kilogram. Okay, and the y here is in cm, so must have the unit. Okay, so your graph is like that, no? Y against the m. Okay, now you have another problem. How to put a number here and how to put a number here? Must refer to your table, you know. Okay, see, look at your table. M, no problem. 0.5, this one okay lah, right? Then y-axis is smallest 0.9, the biggest is 4.5. So meaning that you need to put your scale maybe until 5 enough already lah. This one you put your scale until 2.5. So how you do is, you must make sure that your scale will cover at least 50% of the graph paper, so that your graph you plotted later on, the size is big. Okay, here no issue, you start with 0. You must start with 0 for physics. Why you plotting graph must start from 0, 1. 0, 0 0.5, 1.0, 1.5, and so on. Make sure it's big enough. Okay, now I want you to do like what I did here now. Okay, hold on first. I take some time to make that so that you can see the whole thing. Okay, a little bit smaller. Okay. You see the scale I chose was like this: 0, 0.5, 1.0, 1.5, 2.0, 2.5. This one everyone same. When I do like that, I will count the whole page already. You see, 2.5 mass in kilogram. Whereas on the y-axis side, I put 1.0, 2.0, 3.0, 4.05 because maximum is 4.5 only. So it's big enough already lah. Then I plot all the graph, plot all the dots. Okay. After that, I use a ruler to find the best line. Best line must be, it is impossible for you to draw a line which can pass through all the points. I told you before, impossible one. So what I can do is adjust the ruler to find the best line lah. So best mean must be balanced. So one dot on top here, one at the bottom. I can pass through 3 points. One on top, one at the bottom. I find the balance. Okay. All right. Now plot your graph now. Follow your own value. Here,
No,
everyone
sir.
same. Here may be different.
So the best line must follow, must start from the origin.
Yes. You know why? Because when there is no mass, when the mass is 0, do you think logical you have change in the length?
No.
This one must be 0. When the mass 0, the y also must be 0. Understand,
Okay.
Joel?
Yes,
You
yes.
have to use a little bit thinking, whether need to pass through origin or not. Logically, you think when the mass is 0, no mass shouldn't be any change in the length, so must be 0, 0 lah. Okay. Yeah. All right, now take your time, plot your graph nicely on the graph paper, and then show me
Sir,
your answer. Yes.
graph must use pencil.
Yes, sorry, I forgot to inform you all. Don't do like me, use pens, because I don't have the pencil. Sorry, I don't know why. In my pencil case, I don't have pencil or pens only. For student, use pencil. Everything use pencil. Pencil. Make sure the pencil must be dark enough, very dark one. Okay. All right, everyone plot your graph and then take a pictures of it, and then you share it in the group, the Telegram group. Now, I want you to pass up your graph. Plot your graph, take a picture, and then send through the Telegram group. Don't send personal to me, send into the group. I want to see who are the first one who sent. Then later on test, I give him or her bonus mark. Okay, do it properly, class for size 1. I'm still waiting the first person to send the answer into the group. My phone is ringing. I think someone sent already. I see who was the first one. Okay, the first one is who no name. Teo Si Ming, first one. Congrats. Okay, let me see your graph. Teo Si Ming. Yes, Teo Si Ming, well done. Your graph is correct. The second one is Georgine Yo. Georgine Yo, Your graph is a little bit too small. Too small, you know. It doesn't cover half of the graph paper. Everything nicely done, but the size too small. Okay. So Jim, you too small, you know. You should use a bigger scale, huh? Okay. The graph is too small. And third one is Lim Si Yi. Okay, Lim Si Yi, well done. Your graph is okay, perfect. The next one is Ong Jian Hao. Okay, well done, Ong Jian Hao, correct. This one is Adeline Lim. Zero 0.5, 1.0. Yeah, your graph is not the best graph, you know. Maybe you do like this lah. Adeline Lim, you draw a line pass through the first point and the third point only. Because like this, your line seems like got 2 points below the line. It's not balanced, you know. Maybe you do like this. The best you can do is pass through the first and the third point. Then 2 on top, 1 at the bottom. It still can. Different one, 1 point is okay one. Okay. Adeline can adjust a little bit now. Next one is Aaron Chong. Okay, Aaron Chong, very good. Well done. Your graph is correct. Aaron Chong. Next one is Leong Chen. Leong Chen, your one same problem with another guy just now. The graph, I think, is a little bit too small. You see, probably because I cannot see your graph paper. Your graph is cover half of the page. I think no, right? Leong Chen? Too small, cannot run, you know. Jin Yong. Okay, Jin Yong, well done. Your graph is okay. Next one is Hector Chua. Okay lah. Hector is roughly about 55% of the size. Okay lah, can be accepted. Well done, Hector. Li Yizi. Okay, correct. Yizi, well done. The graph is okay.
I don't know why if I draw the line, it seems like Chachat one. My one.
Which one?
My graph. I haven't sent yet, but I thought because the dots from the graph, the table I made for the spring one.
Memang like that one, you don't get a line pass through all the point one. You only can find the best, understand? Adjust your ruler lah, so that you find the memang is like that one. You always have this kind of problem one. Liu.
Oh, okay.
Sarah, next one is Sarah.
So
yes.
The Y length is what?
What?
The Y length, YCM.
CM lah, is you measure your ruler one, CM lo. Understand?
The CM is the spring one.
Yes. The Y you
I got 9 until 9.
For the first diagram. 9 means 9 lah. You put 9.0 lah. Understand?
Okay,
maybe your printer, your paper is bigger lo. So that's why I told you just now, your measurement may be different one.
Okay.
Okay, Sarah, well done. Your graph is correct. Well done, Sarah. Sim Tek Hong. Okay, Simtech Hong. Okay, good. Okay, well done. When her teacher, I currently using laptop, my phone rosak, so cannot take pictures. Yeah. Okay lah, never mind lah. You send later lah, huh? With her, okay. Later on, when you have a handphone, can take picture, then only you send, okay, understand? How Jiaru. Okay, Jiaru, okay, well done. Your graph is okay. Okay lah. Sean Choi. Yes, Sean Choi graph. So far, I see so many already. Your highest point is only 3 point something only, Sean. Yours or your the maximum extension change in the length is only 3 point something. So okay lah. Accept your value lah, huh? So your graph is well done, okay? Sean is okay. Big enough, very big. Next one is Ong Jia En. Okay, I think your graph should be okay. The size is also okay lah, huh? Because you are very smart, you use a bigger scale in the y-axis, so your graph become longer. So okay lah, Jia En, well done. This one is Celine Lim, okay. Now okay already. Now balance lah. One on top, one at the bottom. Okay, correct. Celine Lim, correct already. Okay, well done. And now you can get a parent, one on top, one at the bottom. Okay, good. Jia Jin, Liu Jia Jin, just now you say Jia Chat one. I don't see Jia Chat. Your graph okay. Liu, not balanced, Your straight line not balanced. You see, you have 4 points under the line. On top, no. So it's not balanced, Liu, you need to draw again, adjust, use a ruler. I suggest you do like this.
I don't know why I have a
Not
hard
balanced. Your graph is not balanced, Jia
time matching them.
You have to use adjust the ruler to find the best line, okay, Jia
I don't know why the dots are separated like that.
Oh, it's very normal. It's normal like that. So
Teacher,
it's
so
up to it's up to
the line
us. I saw your line already. It's not
and the last
balanced.
dot.
You adjust again until you get a balance. Find the balance.
Okay.
Manas, I see your graph. Okay, Manas, your graph is okay. Good. This one is Joel. Okay, Joel, good. Okay, Ken, your graph, good. Cheryl go. Cheryl one can be accepted lah. You have 2 at the bottom, 1 on top, so it's okay lah. Different by 1 point is okay lah, Cheryl. Okay. Any more want to send?
Jay, wait, give me 1 minute.
Okay, Andrew. For those who are already done, you proceed to the last part of the question. Answer the last part. You see the question. Relationship. I think it's they ask you about the relationship. Proceed to the last part. Okay, now who are? Ho Wei Ren. Hold your graph very good, big enough. But the graph is look like bend a little bit. Now I don't know whether your paper, you folded your paper or the line bend. I think it's okay now, Hold big enough, okay? Well done. Ho Wei Ren. Lai Hongji. Lai, you have one mistake. You know why? Your x-axis you never label. Your x-axis you must label. You didn't label your x-axis. Lai Hongji. Then kena minus 1 mark already. Your x-axis you did not label it with a symbol and unit. The rest perfect. Your graph is perfect. Very nice. The only mistake you make was you didn't label your x-axis. Okay. Line, okay, take notes line. Ryan. Not balanced. Below the line you have 3 points, but above the line you have only 1. The gap is 2. Cannot not balanced, Ryan. Okay, I suggest like this you make your line pass through the first point and the third point, then settle. First point, third point, so you have 1 on top, 2 at the bottom. Different by 1 is okay, Ryan. Draw a line pass through first and the third point. Okay. All right, Ryan. Yap Chiao Ân. Okay. Yap Chiao Ân. Okay, your graph is well, perfectly done. Okay, good. Pong Yu Shen. Okay, the graph is okay. Pong. Okay, well done. Hui Ni. Wong Hui Ni. Okay, Wong Hui Ni. Okay, good. Well done. Andrew. Finally, Andrew. Okay, good. Andrew, good graph. Okay, well done.
Thank you, sir.
Okay, welcome. Liu Jiajin. Liu Jiajin, he adjusts already. Okay, Liu Jiajin. Hardly accepted. Okay, Liu Jiajin. But in fact, still got 3 points at the bottom.
Don't know why the dots.
No, the best, I tell you what to do, You make your line pass through the first point and the fourth point. First and the fourth. So let the last point on top, the second and the third at the bottom, then it's better. Okay, Liu?
Also, the line has to match the first point and the last point.
No. Wait, let me see first. No. You draw a line pass through the first and the fourth point.
The fourth point.
Then you will see on top got 1 point, at bottom you got 2 points. Then okay lah.
I go try and arrange first.
Jared. Jared. Okay, your graph is good, Jared. Well done.
Thank you, sir.
Okay, Chua Jia Wen. Okay lah, graph. Okay, good. Well done. Joachim Yu again. Okay, let me check again. Now this is the second time already. Now the graph is big enough. Okay, good. Joachim, now better. The graph bigger than half of the page. Okay, well done. Ryan, do again. And now Ryan. So now at least you got one on top, two below the graph. Okay, can. Ryan? Okay, that's settle lah. Okay, any more? Ryan say thank you. Okay, welcome, Ryan. Yeah. Okay, shall we move to the next one? Okay. Next one is relationship. So how do you think the relationship, the graph like this, how you state the relation? Sean, how you state the relationship of the graph?
Y is directly proportional to M.
Yes, very good, correct. Y is directly proportional. Okay, Y is directly proportional to M. Okay, because it's a straight line passes through origin. So the only answer can be accepted is directly proportional. But you have to say Y first, the Y-axis mentioned first. Y is directly proportional to M. Okay. Okay, we still have another 10 minutes. I want to continue. Last question. Not last, one more. I make it bigger first. Question 16. Okay. A student carry out experiment to investigate the relationship between the length of the simple oscillation pendulum, the length of the thread, and the periods of oscillation T. Experiment repeated using different length. Okay, different length and graph plotted. Now the graph is here. This is a graph. So you can see here, the graph plotted here is T square. I told you why they square it, because they want to get a straight line. T square against the length of the thread here, L. So you can see this is a nicely done straight line, go up, right? Okay, now first question, relationship law. Because you see the graph is a straight line passes through origin, so the answer is T squared directly proportional to L. Okay? The second part of the question. Calculate the period T when the length 45. Show your working standard segment in the SPM. Show your working on the graph. How to find the value T when the L is 45, the length 45. So what you do is like this, you see here. L 45, so it's here lah. This is 40, this is 60 here, 50, so 45 is here. So here you draw a line, use a ruler. This is what you are supposed to show. Use a line, draw, go up, then meet the graph already, then draw another line to the left-hand side. And in my graph, this value is 1.84. Because here is 1, 1.2, 1.4, 1.6, 1.8. So here it becomes 1.84. But not done yet. 1.84 not the final answer yet. Why? Why not the final answer yet? Why though? Yes, because this 1.84 actually is T squared, not T. This value 1.84 actually is T squared. You see the y-axis is T squared. So what are you supposed to do?
Square root.
Square root it. Correct. Thank you. So what you do is like this lah. You show your working like that. T square you get from the graph 1.84 second square. Then you square root it, so you get 1.356 seconds. Square root S square, so you get S only lah. Okay, these are the things they will ask you in your paper 3 lah, your experiment. You do the experiment, collect the data, plot the graph, and they will ask you to answer this sort of question. So you have to sit down quietly to answer the question during your
So need to write.
practical examination. Okay. Yeah, someone asked question I heard. The next, calculate the gradient. Find the gradient of the graph. Can you all do it? Find the gradient. And also same statement they will give, show your working, how you find gradient. Okay. Now you see how I find gradient. Yeah, I make it bigger lah. Okay. So first you got to show a triangle. In physics, first thing, they check your triangle whether you show or not. So I choose a big triangle here. I choose a point very easy to read. Don't choose certain point that very hard for you to read the number one. So I just big triangle like that lah. So over here is 90 cm. Then has cm, so 90 cm. Then over here, 3.8. So 3.8 second square, right? Together with the unit 3.8 second square, here 90 cm. Then easy for you to calculate the gradient. I know some of you can pick the point, right? The coordinate, use a formula. But in physics, actually no need to do like that. You just write the length here, 3.8 second square, here 90 cm. So after that, gradient, you take y divided by x, that's all. Y divided by x. Okay? Take the vertical value, divide by the horizontal value. So you get your gradient. This gradient is positive, going up. So it's positive. Okay? The concept is always right one. When your graph going uphill, your gradient must be positive, cannot be negative. Going down, only negative. Okay? Okay, so now your gradient answer here.
Sure.
Yes.
In the exam, must I show the triangle?
Yeah, correct. In physics, very stupid one, the market schema, they want you to show your triangle, not like your addition max. At max, you just pick the coordinate, you use a formula, can only y2 minus y1, x2 minus x1. But in physics, cannot. You have to show the triangle because 1 mark given to the triangle. Show your triangle lah. You can pick the coordinate, can use a formula, doesn't matter, but you just show a triangle. Understand? You have to show the triangle. Okay, so gradient 3.8 divided by 90 cm. So your answer is here. Yeah. 3.8 second square divided by 90 cm. I change to meter, 0.9 meter. So when I calculate, I get 4.22 second square per meter. This is the final answer.
You can leave it in cm.
Not too that because the next parts the calculation you may need it in SI unit. SI unit is meter, not cm.
So okay. In the exam, if they ask for the gradient, it's best to put on the SI unit
Yes, your best practice is convert all your answer in SI unit. Okay.
All right, thanks.
Okay. All right. Last, before I let you go, calculation. This one let me explain. I want to take some time to explain because using the values of gradient, they say already you must make use of this answer, gradient. And also this formula, t square equal to 4 pi square length over gravity. Calculate the values of gravity, g. Okay, now to find the g, so I put the g over gt square over 4 pi square L. This one you understand, I want to find the g only, put the t square over to dy. I put under L only. I don't need to put under the whole thing now. The reason is why? Because I want to use a gradient because you are told to use a gradient. So in our graph, the gradient is t squared divided by L. You see just now? The gradient is t squared divided by L. Here is t squared. Here is L, right? So our gradient actually is t squared divided by L. Okay, understand for size 1? Okay, and now come back here. Since gradient is t squared over L, t squared divided by L, but here we have L divided by t squared, which is terbalik. So you terbalik this one. So here M also you reverse, so it becomes 1 over M, 1 over gradient. So meaning that you can replace the L over t squared with 1 over gradient. Make sure you understand this part. Okay, this one replaced by 1 over gradient, then put in the gradient value 4.22. Okay, and now finally press the calculator. Pi, you know, use a calculator. Pi, you just press a pi in your calculator. Finally, you get this answer. So this is a gravitational acceleration. Okay. All right. Okay, last part, make sure you take some time to understand it. I need to go now. Yes, any question? Anyone want to ask any question? Yeah. So I stop here for today. You have one more question to go, so you do it as a homework for size 1. Your last question, do it as a homework. Okay, so I stop here. Okay, for size 1. Okay, please on camera, everyone. I take a pictures. I need to have a record. Okay, come. Very fast, just 1 minute only. On camera. On camera, Jiang, I saw you already. Teo Si-ming. Oh, now I know your face already. Oh, Jiaro. Hector, I know you. Xing Yi, I know you. Sarah, I know you. Wen He, okay. Okay, come on. Need to put it down again. Reflection, okay. On very fun one. This online class. Must take pictures some more. Okay, go on. Okay, 1, 2, 3. One more, okay? 1, 2, 3. Okay, thank you for size 1. Okay, so take good care of yourself. So I see you next week. Okay, bye-bye.
Bye.
Bye-bye, everyone. Okay, bye-bye.